11, 10, 9, ignition sequence start.
NASA's Ames Research Center played a critical role in the development and preparation for the flight test of NASA's new spacecraft called Orion. Designated Exploration Flight Test 1, or EFT-1, the mission will provide critical data that will enable engineers to improve Orion's design and reduce risk for the astronauts it will eventually carry. One of the biggest challenges for Orion is that it will re-enter Earth's atmosphere faster and encounter more heating than any previously manned missions, including Apollo and the Space Shuttle.
5, 4, 3, 2, 1.
West models in.
To test Orion's new heat shield made of a material called AVCOAT, Ames used its ArcJet facility to simulate the heating and airflow conditions that occur during atmospheric re-entry. During these tests, the AVCOAT surface reached temperatures of over 3,000 degrees Fahrenheit. Ames developed a group of sensors that was built into the heat shield itself to monitor how well it performs during EFT-1. 34 of these sensors will measure the near-surface and internal temperatures of the heat shield as Orion re-enters the atmosphere. This will give engineers a complete data profile of its performance, allowing them to see what succeeded and how to make future improvements to the thermal protection system. To optimize the design of the Orion crew vehicle, an 8% scale model was coated with pressure-sensitive paint and was tested in the Ames 11-foot unitary transonic wind tunnel. This testing simulated airflow and temperature changes the capsule will experience in flight after re-entering the atmosphere. The data collected is also essential to validating the accuracy of computational models that simulate the performance of space vehicles during re-entry. The Orion launch abort system required testing in the wind tunnels at Ames to better understand the behavior of the system during a complex variety of launch conditions. The focus of the study was to determine the interaction between the plume from the jets with the airflow effects of separation from the rocket. Another test used a 6% scale model of the launch abort system in the 11-foot wind tunnel to find ways of minimizing how loud the system would be during an actual flight. Built in the 1960s to support the Apollo missions, Ames's horizontal free flight facility can fire models through a 75-foot-long test chamber at speeds ranging from 500 to 18,000 miles per hour. Tests of the Orion capsule were essential to understanding how well the vehicle will fly through the air after re-entering the atmosphere, but before the critical parachute deployment. Ames also specializes in the use of computer modeling simulations, referred to as computational fluid dynamics, or CFD. This work has been important to understanding the turbulent wake behind the Orion capsule as it slows down enough to deploy its parachutes. Studies have also been conducted to optimize the thermal heating performance of Orion by using an Ames-developed software tool called Data Parallel Line Relaxation, or DPLR. Engineers will compare their predicted results with actual data from the ArcJet tests and data collected from the EFT-1 flight to improve the DPLR code for future spacecraft design. The scientists, engineers, and researchers at Ames are proud to have played a critical role in the EFT-1 flight test as NASA continues to move forward on its human journey to asteroids and eventually to Mars.